So these are the 6.4 notes, and the objective for today is to use the distributive property to multiply polynomials and quadratic equations in factored form. Now, polynomials just mean that the equation or the algebraic expression just has many terms. It has more than one term, so don't let that word scare you. And the polynomials mostly that we'll be working with are those quadratic equations in factored form. So let's look at some examples here of multiplying these quadratics in factored form. And I want you to understand that the computer, the My Math Lab, calls this distributive property, they call it the FOIL method. And FOIL is just an acronym that stands for the first times the first, outer times the outer, inner times the inner, and the last times the last. And you don't have to remember this acronym. If you just remember to distribute with both terms here, then you'll be fine. So the first thing we want to do, remember, is change our minus signs to plus negative. So the first one I'm looking at here is number 3. So I'm going to multiply 3y times y, and then I'm also going to multiply 3y times 3. So 3y times y is 3y squared, and 3y times 3 is 9y. Next, I'll multiply negative 5 times y and negative 5 times 3. Negative 5 times y is negative 5y, and negative 5 times 3 is negative 15. Now I add my two like terms here in the middle, 9y and negative 5y. So after I add my like terms, 9y plus negative 5y is 4y, I end up with the quadratic equation, or quadratic expression, 3y squared plus 4y minus 15. It was plus negative 15, but I just changed that to a minus. Now let's look at number 6. I've got x minus 9 in parentheses squared. And what I would do on this one, and this is probably a little bit different than the computer tells you to do, but just to make it simple, I would write this out, just expand it, because I know anything squared means I'm going to take that same thing and multiply it twice. So x minus 9 squared means x minus 9 times x minus 9. Now I'll just do the distributive property just like I did on number 3. So first I'll multiply x times x, and then x times negative 9. I'm going to change my minus signs to plus negative. So x times x is x squared, and x times negative 9 is negative 9x. Now remember, I need to distribute again with the negative 9. So negative 9 times x is negative 9x, and negative 9 times negative 9 is positive 81. Now I'll add my like terms in the middle and simplify. So I end up with x squared minus 18x plus 81. Next I'll do number 9. And again, I'm just going to use the distributive property twice here. So I'll do a times a. Let's go ahead and make our minus a plus negative. And then a times negative 11. And a times a is a squared, and a times negative 11 is negative 11a. Now I'll distribute with this positive 11. And 11 times a is 11a, and 11 times negative 11 is negative 121. So I've got a squared plus negative 11a plus positive 11a plus negative 121. Now I'll add the two like terms in the middle. Now what happens here when I add those two like terms, negative 11a plus positive 11a is 0. Those two cancel each other out. So I'm left with a squared plus negative 121, which is the same thing as a squared minus 121. So this particular quadratic equation is called a perfect square binomial. Binomial means it has two terms. It has a squared and negative 121. So this is a perfect square binomial because a squared is a perfect square, because a times a is a squared, and 121 is a perfect square because 11 times 11 is 121. Now number 12 is not a quadratic equation. You'll see that when I multiply this out. But I'll still do the same thing, but this time I'm going to have to distribute with 3 terms here. So a times 3a squared, a times negative 1a, and a times 7. And then I'll have to distribute with 3 terms with the 7. So I'll do that next. Now a times 3a squared is 3a to the third, because remember a to the first power times a to the second power, remember we add the exponents, so it's a to the third power. So a to the first times 3a to the second is 3a to the third. Then I've got a to the first times 1a, negative 1a, that's negative 1a squared, again because a times a is a squared. And then a to the first times 7 is 7a. Now I'm going to have to do the distributive property with this 7 down here. And I'm running out of room, so I'm going to have to go ahead and go to my next line. So 7 times 3a squared is 21a squared. And then 7 times negative 1a is negative 7a. So we'll make that plus negative. And then 7 times 7 is 49. Now, the things that are alike, we've got 2 pairs of like terms here. I've got the a squareds that are alike, I can add those. And I also have these a's right here that are alike, 7a and negative 7a. So I'm going to add those together. So I have 3a to the third, that didn't change. And then negative 1a squared plus 21a squared is positive 20a squared. 7a plus negative 7a cancel each other out. And then I have plus 49 at the end. So when I multiply this polynomial out, that's my answer. 3a to the third plus 20a squared plus 49. Now the last problem I want to show you is number 13, and this should be reviewed from the very beginning of the year, but it's been a while, so I want to review this. So remember that this fraction bar right here means division, so we could rewrite this to be 10 divided by negative 2 times a to the 5th divided by a to the 3rd times b to the 13th divided by b to the 6th. So everything up here is multiplication, so I just kind of separated it out. So we can do 10 divided by negative 2, that's negative 5. And then a to the 5th divided by a to the 3rd. Remember that when you're dividing, you subtract the exponents. So 5 minus 3 is 2, so that's a to the 2nd. And then b to the 13th divided by b to the 6th. Remember, subtract your exponents when you're dividing, so it's b to the 7th. Now again, if you forget that rule about whether you add or subtract or multiply your exponents when dividing, remember you can expand that out. I'll show you here with this second one. A to the 5th means a times a times a times a times a over a to the 3rd means a times a times a. And 3 of those are going to cancel each other. So all that's left are a times a, which is the same thing as a to the 2nd power. So again, don't forget that if you don't remember the rules, expand it out and then you'll see what to do.